Alrighty. In this particular video, I want to talk about basically, as you can see here in the title, blood flow through the heart. And what I am referring to is basically how does deoxygenated blood become oxygenated, and the route that blood is going to have to take to get through the heart in order to make this process happen. Now, before I get into the meat of this, I just want to say that if you're kind of new to the cardiovascular system and you haven't really looked at the heart all that much, I really would recommend you don't go any farther into this video before you really get a good working knowledge of the heart. I have a couple of videos recorded on the gross anatomy of the heart and valves of the heart, what they do, how they work, an overview of all that. So watch those, or if you find someone else, that you like to listen to that, or another heart anatomy video that'll help, fine. But I realistically would recommend that you don't go any further into this video unless you have a good, solid base working knowledge about the structures of the heart, because there's just some inside knowledge you have to have about the atria, the ventricles, and so on, the valves and what they do and all that, because it's very pivotal to understand this process. And this process is just important to understand in general, because when we get to the cardiac cycle, this is all going to come back at you full force if you want to understand pathophysiologies of the heart, like holes in the heart and so on, left to right, right to left shunts in the ventricles. This is going to be important. Let's see what else. Congestive heart failure and unbalanced cardiac output is another good application to this. There's one idea that keeps popping in my head, and I keep forgetting what the heck I was going to say. I forgot. Anyway, it must not have been important, but you get the picture. So again, make sure you have a good working knowledge of the anatomy of the heart first before you go any farther into this video. Okay, and if you do, then great. Let's get into it. So for starters, this is going to be a lot of application of the anatomy of the heart and the structures involved that we're going to be referring to in this. I'm not going to be explaining the real in-depth functions of these structures because I've already done so. But you do need to understand what atria are, and you need to understand that the atria are the upper chambers of the heart, and that they're also the receiving chambers of the heart. So blood enters the heart via the atria. You need to understand that the ventricles are the lower chambers of the heart, and that the ventricles are these are the chambers that pump blood out of the heart. Okay, so blood enters the heart via the atria, blood exits the heart via the ventricles. All right, and you need to understand the importance of not just what the valves are, but just the overall function of valves in the first place. So we've got two types of valves, remember, in the heart. And we've got AV, which is short for atrioventricular valves. And then we've got semilunar valves, and semilunar, half moon. And AV valves are in between the atria and the ventricles. So remember, the atria and the ventricles are separate chambers. And, so let's doodle this out here real quick. So then there's... All right, so we've got upper chambers and we've got lower chambers. All right, and then the atria would be the upper chambers and the ventricles would be the lower chambers. And remember that valves are designed, remember the purpose of a valve is to promote one-way flow by preventing backflow. So valves are designed to open and close at certain points in time to allow blood to flow in one direction when they're open, and then when they close, they force blood to not go back through them, but to go up another direction where there is an opening that they can pass through. All right, and that's not just with the heart. I mean, that's what valves are for. Whether you're talking a spillway dam, whether you're talking a valve in the engine of your car, that's what valves do. All right, so, and then the semilunar valves, remember, are located in the great arteries of the heart. All right, the pulmonary trunk and the aorta. All right, and again, same concept. They're just in different spots. They promote one-way flow by preventing backflow. All right, and then the great vessels of the heart, the pulmonary trunk and the pulmonary arteries. Remember, the pulmonary trunk and the pulmonary arteries are... they're similar in being that they all come from the same structure. That the pulmonary trunk, remember, ascends from the right ventricle, and eventually it will bifurcate and form two separate pulmonary arteries that one will go to the left side, one will go to the right side. So one artery is going to the left lung and the other is going to the right lung. That should just be kind of common sense, but you get the picture. All right. And then pulmonary veins are, remember, veins that carry blood back towards the heart via, and IV or good Lord, i.e. the left atrium. Okay. And the vena, the vena cava, or that's the plural form for the two vena cava. We've got a superior, inferior vena cava, and remember the superior vena cava is draining blood from the head, neck, and the upper limbs into the right atrium, and then at the same time, the inferior vena cava is returning blood from, well, basically everywhere else of the body into the right atrium of the heart as well. And then there's also the coronary sinus on the posterior side of the heart that is draining venous blood from the heart itself back into the right atrium to get oxygenated as well. But we're not gonna focus on that. I have a whole nother set of videos created that are about the coronary arteries, so you can watch those and take a look at them. But so we'll just focus on the vena cava. And then the aorta is the largest artery of the human body that extends out from the left atrium and circulates blood, well oxygenated blood to the rest of the body. Okay. Now, before we get into the overall blood flow of the heart, you have to understand just kind of how the cardiovascular system is organized in the first place. More specifically, how the circulatory system is organized. Now, when we're talking about the circulatory system has two major divisions that we call, that academically are often called circuits. All right, and the two circuits are the pulmonary circuits and the systemic circuit. Now, the pulmonary circuit, I mean, you should just look at the name and already get an indication of what we're referring to here, the lungs. So now, you have to bear in mind that there are two sides to the heart, a left and a right side. There's a right atrium, right ventricle, left atrium, left ventricle. All right. And one side of the heart is handling deoxygenated blood. The other side of the heart is handling well oxygenated blood. All right. And the right side of the heart has deoxygenated blood returning into it, and it pumps blood up into the pulmonary circuit. More specifically, the right ventricle will pump blood up into the pulmonary circuit for the purpose of gas exchange. All right. Gas exchange. Now you get the picture. All right. Now, let's talk about this for a second. All of our lives, from when we were little kids, when we were just learning the real basics about how the human body works, we get into this habit of, and this isn't incorrect. It's just only 50% right. All right. We like to say that the purpose of the lungs is for collecting oxygen, for getting oxygen into our system. And like I said, that's half of the equation. But the other half of the equation, which is just as important, is getting rid of carbon dioxide. All right, so when we circulate blood from the right ventricle into the pulmonary circuit, we're not just doing it to get oxygen, we're doing it to eliminate a waste, a gaseous waste, carbon dioxide. And this is where we do it. So simultaneously, while oxygen is flowing into the bloodstream from the air sacs of the lungs, called the alveoli, carbon dioxide will be diffusing out of the bloodstream, and we will be exhaling that carbon dioxide at some point in time. All right, so you have to keep in mind that, again, I'm going to repeat this. You have to keep in mind that, that's what gas exchange is. We are collecting oxygen in the bloodstream, in the lungs, and we are getting rid of carbon dioxide at the same time. All right. Now, I'm saying this now because, one, it's just important you get into the habit of saying that. But when you get into the respiratory system, you're going to learn more in depth the dynamics of how all of this works. And it's very important that you are in the mindset of just gas exchange, and not just half of this, the oxygen side, that you're also thinking about the carbon dioxide aspect of this, because like I said, they're both happening simultaneously, and they're both of equal importance in my opinion. All right. And so the pulmonary circuit is about gas exchange in the lungs, and the gas exchange that is occurring is we are diffusing oxygen into the blood and diffusing oxygen out of the blood at the same time. All right. Now, the systemic circuit is basically all the other tissues of the body except for the lungs. So, the tissues of the head, the neck, the upper limbs, the abdomen, the organs, some organs of the thorax, the muscles of the thorax, your lower limbs, and so on, all the other tissues of the human body, all right, constitute the systemic circuit. So your viscera, your organs, yeah, same thing. I meant to say your muscles, your skin, and all that. That's the systemic circuit. And the left side of the heart is responsible for getting blood out into the systemic circuit. All right, so the left ventricle circulates blood. Let's abbreviate this, pulmonary circuit. So the left ventricle of the heart pumps blood out into the systemic circuit. And basically what's going to go on here, once blood gets into the systemic circuit, gas exchange is also occurring, except it's the exact opposite of what I just talked about within the lungs. So and you guys know this. I mean, we circulate blood out to our tissues so we can deliver oxygen into our tissue spaces, and then at the same time we will grab carbon dioxide out of our tissues as a waste product and circulate it back to the heart so we can send it into the lungs for gas exchange. So basically that's what the circulatory system is all about. It's just a constant state of gas exchange, except the difference is which circuit are we referring to and what type of gas exchange is occurring. In the pulmonary circuit, we are loading the blood with oxygen. In the systemic circuit, we are unloading oxygen out of the blood. In the pulmonary circuit, we are unloading carbon dioxide. In the systemic circuit, we are loading up with carbon dioxide. All right, so that's basically the circuits, and let's just kind of, want to doodle this out here, just to, just kind of drive this concept home. So if we, do our heart drawing here, and again, I apologize for my horrid art, but unfortunately, I got to subject you to it. Like I always tell my students, you guys are seeing firsthand why I studied biology and not art. All right. Trust me, I know this is a computer and it's harder to draw, but it doesn't get much better on a regular piece of paper or a whiteboard. So, all right, so here we would have the left side of the heart, and here we would have the right side of the heart. And as I was saying a second ago, the right side of the heart is handling the deoxygenated blood. That's why I use blue to represent the right side of the heart. And the left side of the heart is handling the well-oxygenated blood. All right, and remember, like I said, by now, by the time you get to this video, you should understand what the job of atria are. The atria, the upper chambers of the heart, are receiving blood. All right, blood is entering the atria via certain veins of the body, and then the ventricles are pumping blood out into arteries of the body. All right, because again, by now you should just understand the basic concept that all veins of the body carry blood back towards the heart. Arteries carry blood away from the heart, except that what we're trying to talk about here is just what direction specifically and what specific areas of the body are we referring to. All right, so basically what we've got going on here, so we've got our vena cava, superior inferior vena cava that, open into the right atrium. And this, gosh dang it. And this deoxygenated blood will fill up the right atrium. I should probably put a septum here. Will fill up the right atrium and then eventually work its way down into the right ventricle and then up and out, I'm going to abbreviate this, the pulmonary trunk into the pulmonary circuit. All right. And again, for the process of gas exchange, reloading with oxygen, unloading carbon dioxide. All right. And then well-oxygenated blood will, oops, wrong color. And then well-oxygenated blood will work its way back into the left, the left atrium, down into the left ventricle, and then out the aorta, all right, into the systemic circuit. All right, so not only is the right side of the heart pumping blood into the pulmonary circuit, it is receiving deoxygenated blood from the systemic circuit as well. Okay, you have to keep that in mind. And then same thing with the systemic circuit. The left side of the heart is receiving blood from the pulmonary circuit, and then pumping blood out into the systemic circuit. So both of these circuits are interconnected, because of the heart. Even though they are separate circuits, they are, the blood flowing through all blood will flow through both of these circuits just based on the design of the heart. All right. Now, a little bit of application to this. I mean, aside from just understanding where the blood is going, well, let's say we're talking about cardiac output. If you're new to the concept of cardiac output is just the volume of blood that is pumped out of the heart per minute. All right, the volume of blood pumped out of the heart per minute. And usually when you read the books, books will say that the average human has 4 to 7 liters of blood in their body. 5 to 7 liters in the body, 4 to 6 liters in the human body. I usually just like to go to the middle and say the average person has about 5 liters of blood in their bodies. And all right, the average person has about 5 liters of blood, and that's about how much blood will flow through the heart every minute. I'll talk about cardiac output more in depth later on, but let's just apply this here for a second. Let's say someone has congestive heart failure, or CHF, and let's say the right ventricle is pumping out 5 liters of blood. So in a minute, the right ventricle has 5 liters of blood going through it. And let's say the left ventricle only is only pumping out 3 liters per minute. What's going to be the problem here? Blood's going to back up into the pulmonary circuit. All right, because if the right side of the heart is pumping out 5 liters of blood, but the left side can't match that, that means blood is going to back up into the pulmonary circuit. And then as that blood backs up and accumulates into the pulmonary circuit, that's going to cause pulmonary edema. And that's, bad news. And I'll talk more about why that is later on in another video way down the road in the respiratory system. And then vice versa, if the right side of the heart fails, if the right ventricle fails, then let's just flip the numbers around. The left side, is pumping out 5 liters a minute, but the right side is only pumping out 3. Well, then blood is going to back up into the systemic circuit. All right. It's going to back up into the systemic circuit, and then that's going to cause systemic edema. And then you're going to see people with edema in their fingers and their ankles and toes and feet and so on. And either way, edema is bad news. And that's something to talk about later on. But you get the picture. So it's important that you understand what these two circuits are, their purposes, and basically understand that there are pathologies that are related directly to these circuits. All right. So keep that in mind. So now let's actually get into this process. And I absolutely love this picture because it has just the right amount of detail in it, and I don't have to subject you guys to my horrid art. So I like to think of this as kind of a 10-step process. Some people may, 14, 15, 12, 13, 16, whatever. Like I said, I like to think of this as happening in 10 different steps. All right. So now, before I get into this, first you need to understand this. I'm going to be talking about this step by step from side to side. So, for example, the first step of this process would be deoxygenated blood is going to enter the right atrium through the superior and inferior vena cava. So we'll say that's 1. We'll say the right atrium filling up is 2. Okay, so blood returns to the heart through the vena cava, superior, inferior, and it's going to fill up, and also remember the coronary sinus, and it's going to fill up into here. And then it's going to go down to it's going to pass by the tricuspid valve and fill up in the right ventricle, and so on. Now, you have to bear in mind that even though I'm going through this one step at a time, in real time, real life, that both atria are going to be filling up simultaneously. All right, and while the atria are filling up, the ventricles are going to be contracting simultaneously, and then vice versa. When the atria are pumping blood down into the ventricles will be simultaneously relaxed, and the atria will be simultaneously contracting. Now, all 4 chambers never contract at the same time, but all 4 chambers will also never pump at the exact same time either. That just wouldn't make any sense. If all 4 chambers all squeeze at the exact same time, there wouldn't even be any pumping of blood out of the heart in the first place. All right, or in amounts that were so minimal we wouldn't be able to live. So you have to keep that in mind. Even though I'm going through this one side of the heart at a time, and like I said, in real time, real life, normal situations, the atria are working at the same time. The ventricles are acting at the same time. Okay? So let's continue with this. So deoxygenated blood from the systemic circuit enters the heart through the superior and inferior vena cava, and eventually the right atrium will fill up with blood. And then eventually the tricuspid valve will open up, and now that there's an opening between the atria and the ventricles, blood will just fill into the ventricles. So we can call that step number 3. Now let's just think about this for a second. It's really easy to fill the ventricles up with blood because remember, the atria are the upper chambers of the heart. If you pop open these valves, gravity does about 80% of the work for us. The atria barely have to contract to really get a lot of blood out of themselves into the ventricles because gravity is working in our favor, which is good. That's a good energy saving tactic. All right, so when the tricuspid valve opens, about 80% of the blood that is going to fill in the ventricles or in the left side as well, like I said, remember this happens at the same time, 80% of ventricular filling is passive filling. And then when the atria do contract, and that's called active filling, that only constitutes 20% of the rest of the blood that's going to get in here. Okay, so on the right side here, blood will pass by the tricuspid valve, and then it will fill up the right ventricle. And then when the ventricles are stimulated to contract, then the force of the contraction will make the AV valves shut, the tricuspid and mitral valves. And then what'll happen, now this picture is really well drawn because notice the design of the tricuspid valve here. Notice how it's curved the way it is. When this ventricle is contracting and forcing blood up against the cusps of the valve, well, that's gonna just force the valve to stay shut even tighter. But notice the shape of the semilunar valves. It's easier to push those open. So when the ventricles are generating force, these semilunar valves will pop open. And then in this particular scenario, blood will ascend the pulmonary trunk, and then it will fork into the pulmonary artery. So we could say this is overall is step number 4. All right, so blood going from the right ventricle up through the pulmonary trunk and then through each pulmonary artery into the lungs. All right, it's pretty easy. Then this is where, kind of back what I was just talking about a second ago, this is where gas exchange occurs. And I'm just going to abbreviate this in the pulmonary circuit. All right, the pulmonary circuit, and we'll just say step number 5. All right, step number 5. So gas exchange occurs in the pulmonary circuit. And remember, in this particular scenario, when we're talking gas exchange, we're going to have deoxygenated blood coming in, and we're going to have well-oxygenated blood coming out. All right, so we are reloading with oxygen and we are unloading carbon dioxide in the lungs. All right, and then we'll talk more in depth about that in the respiratory system later on. But for now, that's what you have to understand about the lungs, the pulmonary circuit, and gas exchange. All right, so now what's going to occur is that blood will circulate back into the lungs through the pulmonary veins. All right, through the pulmonary veins. So the right and the left lung both have two pulmonary veins that will eventually two pulmonary veins that exit the lungs that enter into the left atrium. And remember, you can't see much of the left atrium in this picture because the bulk of the left atrium is on the posterior aspect of the heart. All right, and so but the left atrium is eventually going to fill with this well oxygenated blood. All right, we'd say we'll call that step number 6. All right. Now, what else did I want to say here? So now notice here, I use blue for the pulmonary arteries, the pulmonary trunk, pulmonary arteries, and I use red for the pulmonary veins. Now you're thinking, now you're normally schooled to think that, well, red means arteries, blue means veins. What's going on here? Now bear in mind that think of the overall function of arteries and veins again. Even though this artery is carrying deoxygenated blood, that's why it's colored blue, it is still doing what an artery is doing, the pulmonary trunk and the pulmonary arteries. They are circulating blood away from the heart. That's what arteries do, all right? They conduct blood away from the heart. And then the pulmonary veins, you know, this is really the only spot in the body where you're going to see veins circulating well oxygenated blood. They are going to carry well oxygenated blood back towards the heart via the, you know, into the left atrium. So even though they're red, they're carrying well oxygenated blood, which is atypical of veins, they're still doing what veins do. They're carrying blood back towards the heart, the left atrium of the heart. So keep that in mind. Don't let those colors screw you up. They're still doing what arteries and veins do. All right. So then, once the left atrium fills up with enough blood, the mitral valve will open, and then boom, it'll fill up with, the left ventricle will fill up with blood, and it will be circulated. You know, it will fill up with blood, and then eventually the left ventricle will contract. I'm sorry. And remember that the mitral valve will then shut. Blood will not be able to get back through here because of that tight seal created by the closing of the valve, and then it will go out the aorta. All right, go out the aorta. All right, and then remember there are three parts of the aorta: the ascending, the arch, and then the descending aorta. And then that blood will go out the aorta, and then basically to the rest of the body, into the systemic circuit, all right, for gas exchange. All right, so in the systemic circuit, we've got well oxygenated blood going out to our tissues, and by the time they go through the tissues, we've got deoxygenated blood. So we got gas exchange occurring in the opposite here. All right, and so basically we are unloading oxygen, and we are reloading with carbon dioxide. And then this process just starts all over again. This blood will then eventually work its way back up through either the inferior or superior vena cava, and then this process starts over. I mean, that's basically how this works. All right, and remember that it's important that the two sides of the heart, I mean, not just the four chambers of the heart, but both sides of the heart are separated from one another. That's why there is this septum, this interventricular septum in between the ventricles, because, you know, I talked about this in a previous video, and I'm going to bring it up again. We don't want mixing going from either left to right or right to left. All right, it's a lot more dangerous to mix from right to left, because if this deoxygenated blood mixes up with this well oxygenated blood, then that blood's going to get out into the systemic circuit, and we're not going to be delivering enough oxygen to our tissues. If we mix from left to right, it's not as dangerous, because that blood will just work its way back up into the pulmonary circuit, and it'll recollect oxygen, but you're probably going to have a decline in cardiac output, and you may not be getting enough blood out to your tissues if you're mixing the other direction. So they both have their drawbacks. Just one is just, you know, right to left is just more dangerous. Those are called shunts. All right, and then I said 10 steps earlier, and I was thinking, you know, saying, well, step number 10 would be starting all over again, but that would be ridiculous. So we'll just say that there are 9 steps in this process. So again, just to review, you know, blood, you know, comes in through the vena cava and fills up into the atria, or into the right atrium, and this blood is deoxygenated. And then that blood works its way down into the right ventricle, and then eventually, and in doing so, it passes by the tricuspid valve, the right AV or atrioventricular valve, and then this blood will ascend up into the pulmonary trunk, because the tricuspid valve will shut and prevent the backflow of blood, and so blood will only be forced in one direction out of the right ventricle up through this particular semilunar valve, the pulmonary valve, into the pulmonary trunk, and then into the pulmonary arteries. And I guess, you know, if you want to really make this into 2 steps, I guess that's why I was thinking 10 steps before. You could say, you know, 4, you know, pulmonary trunk could be step number 4, then the arteries could be step number 5, but realistically, it's just more, you know, if you understand the process, that's more important. It's not the number of steps that counts. All right, and then we will undergo gas exchange in the lungs. All right, remember, deoxygenated blood will work its way into becoming oxygenated into the, remember, this would be the pulmonary circuit. All right, and then that well oxygenated blood will work its way back into the heart via the pulmonary veins, and the pulmonary veins will drain into the the left atrium from both lungs. All right, and then blood will work its way down into the left ventricle, and then eventually it will fill up, mitral valve will shut, prevent the backflow of blood, and then blood will be forced out through the pulmonary valves into the aorta and out to the systemic circuit for gas exchange, where it's just going to be the opposite. We're getting rid of oxygen and loading up with carbon dioxide so we can carry that gas to the lungs and exhale it, because that's really the best way we have of getting rid of carbon dioxide. That's why we have these two circuits in the first place. So this is basically the overview of blood flow throughout the heart. I hope this helps. I strongly recommend you sit here and you really get this to the point where you can just recite it in your sleep, the step-by-step process. Again, don't necessarily focus on the number of steps, just on how this process works. And a good way to study and to practice this is to see how much of this you can write out on just take a pen and paper and sit there and try to write this out step by step, whether it's in paragraph form, if you're drawing arrows, if you're diagramming this. If you can just do this all off the top of your head on a piece of paper in front of you, and you're getting to the point where it's comfortable and easy, then you really know this. So that's honestly a good way to kind of practice that. So I have my students do that. I kind of did it myself when I was a student, and it works very well. So I hope this video helps. If you have any questions, feel free to contact me and ask, and keep working hard and studying. Take care.